Hello guys, welcome back to Global Education Zone. And in this sixth episode of our volume mathematics for SS1, we're going to be dealing with inequalities. Now, I want to talk about inequalities. Inequalities, they are basically like equations, but the only difference between equations and inequalities is that inequalities, they do not have equal signs. So in this case, you are trying to say that something is not equal to another thing. So, but the the kind of inequality, they are often of two types. Rather, we can call them four types. There are four types of inequalities. So inequalities, you have the greater than or equals to, lesser than or equals to, you have the greater than, and you have the lesser than. So, but basically, in this video, we are going to be dealing with inequalities proper. We are going to be dealing with inequalities proper, and hopefully, we are going to deal with a lot of concepts involving inequalities. So let's delve into the course. So we have some performance objective for this course. So we have some performance objective. The first thing we are supposed to achieve today is we are supposed to solve inequalities in one variable. Yes. Then also we should solve inequalities in two variables graphically, and also we should be able to apply the solutions to these inequalities. We should be able to apply the solution to these inequalities. So first of all, we'll start by solving inequalities. We'll start by solving inequalities in one variable graphically. So basically, let's have the laws of inequality. So inequalities, they don't just exist, they have rules which govern their existence. So that's why we have the rules of inequalities. So the first rule of inequalities we have in here is is displayed on the screen right now. So we have the if A is lesser than B and C is lesser than 0, then A plus C is lesser than B plus C. So basically, if A is greater than B rather, and C is greater than 0, then A plus C is lesser than B plus C. Then also have if A is lesser than B and C is greater than 0, A plus C is lesser than B plus C. So basically, these are just simple rules of inequalities that govern the behavior of inequalities, and you also have examples. So for a first example, they said 3 is greater than 2. So that means 3 plus 4 greater than 2 plus 4. Simple logic. They also have 2 is lesser than 5. That means 2 plus 3 will be lesser than 5 plus 3. So in essence, what we're trying to show here, we're trying to show that these are constants. So these constants, they have their certain behaviors. So based on how they work. So these constants, when they're added on both sides of the equation, they don't change the sign. But when you're adding negative numbers, it might give a different result. So let's explore what happens with negative numbers. Let's start from there. So we have the next part of this concept. So if both sides of an inequality, so listen carefully, if both sides of an inequality are multiplied or divided by the same positive number, then the sense of inequality remains unchanged. So basically, when they say sense of an inequality, sense of an inequality is talking about the sign of the inequality. So when I talk about the sign of an inequality, it has to do with the fact that these inequalities, they have their arrows. So some have the greater than arrows, some have the lesser than arrows. So that is called the sense of the inequality. So that sense of the inequality, which is the sign of the inequality, when you multiply or divide an inequality by the same positive number, then the sign or the direction of that inequality will not be changed. To still be the same. So we have in this example on the screen here, we have in this example on the screen, we have some examples here. So let's do the first example. Here we have an example 3, the number 1, which says 10 is lesser than 8 and 2 is lesser than 0. Therefore 10 times 2 is lesser than 8 times 2. So in this case, when you multiply both sides by the same value, then it does not change the sign. Also, when you divide both sides, for example, in the fourth example, you have 5 is less than 10 and 5 is greater than 0. So when we divide both sides by the constant 5, our the sense of an inequality, or let's say the direction of the inequality, remains unchanged. So in this case, consider that that's lesser than inequality. So by the way, it looks like I've skipped a particular concept. Which I should have introduced, I have talked about. So let's talk about that concept, and that concept has to do with the existence of signs. So just as a revision for those of you who might not understand, anytime you have an inequality. When you bend your left hand, you have a left inequality, which is a lesser than inequality. Then when you bend your right hand, you have a greater than inequality. So basically, when you are drawing on the board, that will be lesser than, that will be facing this direction. But then the greater than will be facing this direction, which is the curve or angle made by the right hand. Then we also have the third type, which is a combination of this and an equality. So when you combine an inequality and an equality, you get lesser than or equal to, denoted like by a dash under the lesser than. Then we also have greater than or equal to, also denoted by a dash under the greater than symbol. So that is the basic concept of representation of inequalities, and I hope you understand that concept. Let's move on to the next concept for this video. We are talking about if both sides of an inequality are multiplied or divided. So listen carefully. If both sides of an inequality are multiplied or divided by the same negative number, then the sense of the inequality is reversed. So in this case, when we have negative numbers, they actually function to reverse the sense of our inequalities. So basically, whereas in the first instance, we're having a non-reversal of inequalities, but when we put negative numbers into the picture, it reverses the sign. For example, let's look at this example on the screen here. So in this example on the screen, we have basically we have number of figure 1 as 5 is greater than 3 and minus 2 is lesser than 0. So if we multiply both sides by negative 2 or minus 2, we'll have on the left hand side that will be 5 times minus 2, on the right hand side that will be 3 times minus 2. So but in this case, it will reverse the sign of the inequality, and instead of the greater than which it was before, it will now become lesser than. So that is the concept you need to understand. So I hope you understand that concept. So now that was for that example. Let's move on to something else. So the next concept we have here is which is the fifth concept for this video. So I hope you are understanding this video. If you are, don't forget to like, share, and subscribe. Let's deal with an example. Yes, we are going to be dealing with examples. Then we'll be delving into quadratic inequalities in one variable. So in this example, we have a simple example here where we are told that if a and b are both positive real numbers, so that a plus b divided by the square root of ab is greater than or equal to 2. So now this is something that is quite can be quite tricky. It's an example where we have to show, but it's simple. Just take it simple and calmly. So they said a and b are both positive real numbers, right? So they have to show that a plus b divided by the square root of ab is greater than or equal to 2. That means a plus b over the square root of ab must be greater than or equal to 2, right? So now let's check that out. Let's now I must mention that the rules of equality apply to inequalities, but the only difference is that in this case, in the case of inequalities, you don't have you cannot assume that they are equal. But the only thing, all your algebraic rules that apply to inequalities will also apply to inequalities at the same time. So let's move on. That being said, that means we can also cross multiply. We can divide both sides by a particular integer. We can perform any arithmetic operation on an inequality just like an equality, but the only difference is that they have different signs in between them, in between the left and right side. So let's multiply both sides by the square root of ab. That will be a plus b greater than or equals to 2 root ab. So that's the procedure of multiplying both sides by the denominator on the left hand side. So then we have so now we have these are positive numbers a plus b, and we have to show that that is greater than or equals to the square root of ab. So basically this will involve, so let's break it down. A plus b greater than or equals to root ab. So can we put it in this format? Let's convert this one into this format. So let's have it this way. We can say roots. This is the root a square plus root b square. So in that case, that will be greater than or equals to root ab plus root ab. So if you don't understand why this is so, you can watch my previous episode on sorts. So in that previous episode, I talked about why sorts are awesome and how you can perform different operations with sorts. So that episode was actually awesome. You can check it out. So let's continue the concept. So I was talking about that. Let's move on to now. I want to compare both sides now. So this is root a square plus root b square, and this is root ab plus root ab. So obviously, when you take any number, when you square a number, the square of a number will always be higher than the twice of that number, obviously, except for 1 and so on and so forth. So if no matter what a and b is, the square of b will always be greater than this product. If a is lesser than b, but if a is greater than b, it might be less. But looking at this from a very careful perspective, you will agree with me that this is like the equation where we have a square plus 2ab plus b square. So you agree with me in that case. So this is root a times root a, that's root a squared plus root b squared. That is greater than or equals to root 2 root a times root b. Yes, that is obviously true, because if we take this to be a square, when we assume that root a, let's root a equals a, if root a is equals to c and root b is equals to d, that means c square plus d square is greater than or equals to 2cd, which is actually true. It's actually true, because when we move this to the right hand side, c square plus d square minus 2cd will be greater than or equals to 0. And then when we convert this to the format, to the so we have c minus d squared is greater than or equals to 0. So the reason for this is that we know when you expand this, you will get c squared plus d squared minus 2cd. That is the normal result. So we just reverse the product. So c squared plus d squared minus 2cd equals simply equals to this, the square of c minus d. And you know that the square of any number is always positive, and because it's positive, it is as result greater than 0. That means this term on the right hand side will always be greater than 0, and which is also greater than the term on the right hand side. So the square of any number is always greater than or equals to 0. So that means if c equals d, it will be equals 0, but on any other conditions, it will be greater than 0. That's why it is greater than or equals to 0, and that's why it is valid. So you can try those examples, and you can try them. You can see how they go. You can try the examples, and let's see how the solution goes. So basically, that is the concept we're trying to talk about here. Let's move on to another concept in this video. So let's talk about another concept, and this other concept we're talking about here, it is a concept that is quite essential in salt when you want to understand salt. So which is quadratic inequalities. So basically, we often deal with quadratic inequalities in different cases. We deal with quadratic inequalities in different cases. So that's why we're giving an example. So I've done a full-blown course in mathematics for SS1, SS2, and SS3 in this channel. You can check out the link in the description of this video. I would put the link in the description of the video. And so I hope you understand that part. So I've talked about sort, but I will still brush it because it's further mathematics, which is obviously a step ahead of mathematics. So let's move on to so in this question we are asked to determine the solution set of the inequality. So when we're trying to determine the solution set of an inequality, basically what we're trying to do here is we're trying to look for the values that satisfy that inequality. That's what solution set means. So in this case, we have this question here as figure 6. So we are determining the solution set of x squared minus x minus 10 is lesser than or equal lesser than 2. So the solution is as follows. So basically we say if x squared minus x minus 10 is lesser than 2, then x squared minus x minus 12 is lesser than 0. Because when you move the 2 to the left hand side, you get negative 2. That would add to the negative 10. That would become effectively negative 12. That's minus 12. So then at the end of the day, we have the zeros of the functions, because x squared minus x minus 12 is lesser than 0, right? So if we if we look for the zeros of the function, now I must say that the zero of a function is a particular point in that function where the the y value, or the ordinate value is 0. So when y is 0, that is the zeros of the function. So let's move on. So at this particular zeros of the function, we have our y value as 0, and then at the end of the day, when we evaluate that, we have we factorize the right hand side, so that's x plus 3 x minus 4. So that at the end of the day, we have x equals minus 3 or x equals 4. So you can see the graph here. It's plotted on a graph. If you don't know how to plot a graph, you can check out my course for SS1 mathematics. I've done a full-blown course for mathematics in if you're in SS1, or if you don't understand this concept, the basis of mathematics. There's a particular course for that. You can check that out on this same channel. So let's move on. So that is the solution of this question, and then you can see it represented on the solution set. So the solution set is kind of like a line of numbers from negative to through to 0 through to positive. So in this case, we have the lower value of x. So we said earlier that x is minus 3, are we? So this minus 3 will make a circle above that value on the number line. Then we'll also go to the next value of x, which is 4. Then we'll make a circle above the number 4 on the number line. So you can see that number at the bottom of this screen. So the arrow, the line with arrows and numbers. So that is called the number line, and that is one way you can represent your answers in SOD. So I hope you understand that concept, and I hope you will be able to deal with such questions if they happen to come in your way. So let's move on to another concept in SOD, and that is the concept of absolute values. So absolute values, they are not very difficult. They are basically values that have two possible outcomes. So when we're dealing with absolute values, we'll often be dealing with a kind of bracketed figures in the questions. And then in this case, for example, this absolute value here, we have if a number x is positive, the absolute value of x is denoted by absolute x, and it is x itself. So if the number x is negative, then the absolute value of x is minus x. So basically, the absolute value of x, sometimes called modulus of x, is defined precisely as absolute x equals f x is greater than 0, and minus x if x is less than 0. So the absolute value of a number gives the magnitude of the number regardless of the sign. Yes, and it denotes the distance between 2 points without paying any regards to the sign. So basically, for example, let me explain the concept of absolute value so that you can understand better. Now I want to talk about absolute value. We're talking about the fact that in absolute value, you can have a number, and that number, regardless of the sign of the number, you will still have the what we care about is the modulus of that number. So for example, when we are dealing with absolute values, we're talking about concepts like this. For example, the modulus of the number is the magnitude of that number. If we have 5, now this 5 has a magnitude of 5, and also you agree with me that this minus 5 has a magnitude of 5. So they are positive numbers and they are negative numbers. 5 is a positive number, minus 5 is a negative number. But each of these numbers, each of them have a magnitude of 5 because that is the value you can see on the screen. But this sign, it is not relevant to the absolute value. So when we're looking for the absolute value of 5, we'll give it as 5. And when we're looking for the absolute value of minus 5, we'll still give it as 5. So that absolute value, it does not care whatever the sign is, whether plus or minus, it will still give you the value of the face value of that number. So that, I hope you understand that concept of absolute values. So let's give an example based on absolute values. So this example on absolute values, we are dealing with it in little by little. So basically, we have this. So here we are asked to find the solution set. We have to find a particular solution set. So basically, this solution set is we have the solution set as here. So on the screen here, you have the absolute value of 2x minus 3. So that is how it is denoted. Absolute value of 2x minus 3 is less than 4. So you basically begin to understand that since absolute value can take either negative or positive, then you can actually divide into two parts. So that means either 2x minus 3 is lesser than 4, or 2x minus 3 is lesser than minus 4. So because any number has two values, the positive and negative values. So any modulus of a number rather has two positive or possible values. So in this case, then 2x minus 3 is less than 4 if 2x minus 3 is So and then x is less than 7 over 2, or we can say minus 2x minus 3 is less than 4. So at the end of the day, we are taking the negative value of that absolute value. So and then when we solve the both of them, we have x is less than 7 over 2, or x is greater than minus 1 over 2. So those two values, when you plot them on a number line, you will then get your answer. So that number line gives us the answer. And don't forget that you shade the circles on above those circles above the numbers. They will be shaded if it is a partial inequality. That is, if you have an equal to bar under the inequality. For example, greater than or equal to is a partial inequality, and then lesser than or equal to is a partial inequality. So it's either lesser than or is equal to. So that's what I call them. I don't know if that's what they actually called, but that is basically what I call them. So at this juncture, we've come to a particular point in this video where I believe you guys will be able to understand the concepts I've introduced so far. So at this stage, I guess we'll call it a day for this course in absolute values. Then, but I'll actually give a kind of summary of everything we've talked so far, because I like giving summaries because it makes you understand better. So the summary of what we've talked in this video, basically, we've talked about a number of concepts. We'll talk about the basic rules for solving linear inequalities, and they are also similar to the basic rules for forming equations, but in this case, inequalities, they have different directions. Then we'll talk about the solution set of linear inequality, the absolute values, and then the representation on an xy plane. So I hope you understood this concept, and I hope to see you next episode. Thanks for watching.